So today we are talking about your rational expressions. You guys are going to learn how to simplify, multiply, and divide rational expressions. And actually, this might be a review for some of you all, because I believe they actually do it in Algebra 1. So it's going to be a good old review. We're just incorporating a little bit more challenging factoring that'll go into it. But factoring is definitely going to be one main premise of this. So please make sure you guys have down your goal. Go ahead and open up your foldable to the little flap for simplify, and as you can see, to simplify rational expressions, you want to, excuse me, factor all expressions, numerator and denominator, and divide out common factors, okay? So to simplify rational expressions, you want to factor out all expressions, top and bottom, the most that you can. Sometimes you might not be able to factor it out, okay? But if you can, you want to. And then divide out any common factors, all right? The most challenging that this will get depends on the original rational expression. And if you're curious what a rational expression is, it's basically a fraction that has a function on the top and a function on the bottom. Okay? That's what makes a rational expression. It has a function on the top and a function on the bottom. So we're going to simplify each one of these rational expressions. And if we can, sometimes we won't be able to. And then we're going to find the excluded values, aka the constraints, aka what makes the function undefined, interval notation, set notation, the last unit. That was a legitimate call. Okay? So, you haven't left that yet. When we look at example 1, if you know, example 1 is very simple. Example 2 gets a little bit harder. 3 gets a little bit harder. 4 gets a little bit harder. Okay? So, these are the very simple ones. If you look, you pretty much are reducing the fraction. Okay? You have a monomial over a monomial. Very simple. How does 6 over 15 simplify? You divide by 3, the top and the bottom, right? Whatever you do to the top, you got to do to the bottom. What's 6 divided by 3? 2x. And then what's 15 divided by 3? 5. We took out the common factor, which was a 3. We canceled that out, and we were left with 2x over 5. Now, does this one have any excluded values? Is there going to be anything that's going to make the denominator 0? So we don't do it for this one, okay? Well, you can't, because, I mean, technically, with a fraction, you can't have 0 in the denominator. And when we said 5 equal to 0, that's not possible. So in this case, there's no excluded values because there's not going to be anything that we could plug in for x that's going to make it undefined. All right? Let's look at B. We have 15x squared divided by 25x cubed. Say what? Each term has a 5x squared. That is the common factor with the top and the bottom, a 5x squared. So when I divide 15x squared by 5x squared, what am I left with? I'm left with a 3 on the top over a 5x on the bottom. Okay, so I divided each, the top and the bottom, by this common factor, which was a 5x squared. Is there an excluded value for this one? 0. X cannot equal 0 because that's what's going to make the denominator 0. So find the excluded values. X cannot equal 0. If I ask you to write the domain, boom, you're already in set notation. Okay? Or if you want to write an interval, negative infinity to 0, 0 to infinity, parentheses everywhere with the unit. Because we didn't have a variable in our denominator. We just had a number. So anytime we have a variable in our denominator, we want to make sure that we state that. What about in C? What is the common factor in C? An 8x. So when I divide a negative 8x by 8x, what am I left with? Negative 1. And on the bottom, a 3x. Do I have an excluded value? 0. So my excluded value, x cannot equal 0. Those are the easy ones. Questions? Yes. Oh, I see what you're saying. We could have written it like this, I did skip that step. I could have done 3 times 2x over 3 times 5, then canceled out that common factor, and I still would have been left with that there. Yeah. Okay. Now let's look at number 2. Number 2. Can I factor at the top, any? How so? I can take out a 4. That's a GCF, right? When I take out a 4 from the top, what am I left with? X plus 3. Can I factor the bottom? I could take out a 4, right? Cancel out the common factors. Do you want me to write that, or do you just want me to leave it as 8? All right, I'm gonna leave it as an 8 because realistically, when we get to the more challenging ones, I would leave it as an 8. All right, but from here, let's cancel out the common factors. 4 and 8, they have something in common. What is it? A 4. So if I simplify this 8 is going to turn into a what? A 2. So then my final answer is going to be x plus 3 all over 2. And then there's no constraints. There's no excluded values because we have a number in the denominator. Okay? Questions? Let's look at B. Is B going to have a constraint? Wait. A constraint, an excluded value. What is it? X cannot equal -6 because we have to set our denominator equal to 0 to find exactly what X value is going to actually make it equal to 0. Thanks, Jeff. It's not. Oh, it's not? Okay. Okay. So we got our excluded values out the way. Let's simplify it. The top, it has a GCF. What is it? 7. So if I take out a 7, that leaves me with what? X plus 6. Can I factor anything out of the bottom? And what do you see? The x plus 6 is canceled out. So when I simplify this, what am I left with? A 7. That's it. Yes, it can be a number. If what the top and the bottom have in common leaves you with just a constant of value, then that's fine. It's perfect. Because if I plug in 0, that's not going to make the function undefined. But if I plug in a -6, a -6 is what's going to make the denominator 0. So remember, when we were doing this back from the last unit, you want to set the denominator equal to 0 and then solve that because that's the value that's going to make the function undefined. How is this? It's all right. Main thing is factoring, simplifying. Now, real quick, I'm going to add this in. All right. Because it's going to happen, and I'm trying to do some damage control. Okay. You cannot do this and say my answer is 3 over -2. Why can I not do that? It's a whole thing. It is x plus 3 together and x minus 2 together. By canceling out an x, you're basically saying that the common factor between the top and the bottom is an x, and it's not. X minus 2 comes together. You just can't take the x away from the -2. You can't do that. Now, there are a couple. Now, if you had this, then I could cancel it out because they both have a common factor of an x. So I can do this, but I can't do what's on the top. So please, don't do this. Do this. Okay? It's going to happen. And I say this now because we're about to get to the ones where I can see it happening. The only time you can cancel things out is if they're common factors. Not common terms, common factors. Okay? Yes. You still can't do it. You say if it's 2x plus 3 and 2x minus 3, or 2, what'd you say, 2x minus 3? Mm-mm. Because there's still not a common factor that can cancel out. Now let's say this was a 2x plus 6 and a 2x minus 2. Isn't there a common factor in the top? It's a 2. Isn't there a common factor in the bottom? So here I could cancel out the 2's, but that's all I can cancel out. Yes? You said 3x over what? Now, great question. Yes, you can cancel the x's here. It is a term. And if you really want to think about it, this is 3 times x. This is 2 times x. And when things are being multiplied, then yes, you can cancel out because those are common factors. If I wanted to, I could factor out an x from the top and the bottom and cancel those out. So then that would work. So there's addition or subtraction. You can't just cancel terms. Okay? It's got to be multiplication. All right. Let's look at these. Let's factor. How's the top factor? A 2. Okay. So that gives me, am I stating constraints? I'm not stating constraints for this one. Or is that part of the directions still? Never mind, it's still part of the directions. So let me do that first. Always do your constraints first. Always state your excluded values first. When I look at the bottom, what do you think I should do to the bottom first before I start stating constraints? Okay, if I set this equal to 0 and solve it, how do I solve? Add 9, then square root it, and please tell me what's the answer.
Positive or negative 3.
Say what, Joey? Positive or negative 3. Don't forget, when you take the square root, it's plus or minus that value. So these are your excluded values here.
Always state those first. Always do your excluded values first.
Always state those first. Always do your excluded values first.
Now let's factor. Take the top out.
Now let's factor. Take the top out. What do I take out of the top? A 2. What am I left with?
And how does the
X plus
bottom
3.
factor?
And how does the bottom factor? Look at the bottom. It's difference of perfect squares, isn't it? X squared is perfect square. 9 is a perfect square. That's why I took that time at the beginning to go over it. Because you're going to see these throughout this entire unit, this first half of the unit. Do they have anything in common that I can cancel out? X plus 3. So when I cancel that out, what am I left with? And that's my answer. And I really like this unit because, like, once you've done all that work of factoring, things just beautifully cancel out. Sometimes you're just left with 1. It's beautiful. It's beautiful. Okay. Now I have to factor. B. Okay. Oh, I need to state my excluded values first. If I set my denominator equal to 0, what am I going to have to do to solve it? Not too much. How do I solve a quadratic? I need to factor it. And considering that I need to factor it to simplify, I'm like killing 2 birds with 1 stone. So when I find my constraints with my denominator, I'm also figuring out what my denominator factors down to be to actually simplify it. So let's make our x. I'm going to make it tiny. What goes on top? On the bottom. What are my 2 numbers? Awesome. So this becomes 5, x plus 5, x minus 3. So what are my excluded values? So those are my excluded values. And we always do those first. Now let's simplify. I already did the hard part for my denominator. What about the top? Same thing. What goes on the top? Bottom. What are my two numbers? And 5. So that's x plus 1, x plus 5. Does anything cancel? And I'm left with questions. If that was the original problem that we were given, x plus 1 over x minus 3, we wouldn't be able to simplify it any further. But we can state constraints, though. Yes. How is this? It's factoring. In the end of the day, it's factoring. That's why I spent 40 minutes at the beginning of the class going over factoring. Okay? Let's look at A. For example, 4. Okay? What, let's do my constraints. When I set my denominator equal to 0.
How do I solve this?
How do I solve this?
Subtract 1 and then
Subtract 1 and then,
a step. I'm just gonna add.
okay, so to save a step, I'm just going to add x squared.
Square
Now what do I need to do?
X is gonna equal what?
Square root. So x is going to equal what?
Those are my excluded values.
Plus or minus. Those are my excluded values.
Let's do this. How does the top factor?
Let's do this. How does the top factor? Say again. 4, negative 1. So that's going to be x plus 4, x minus 1 for the top. Now the bottom. The bottom is a tad bit tricky. The reason why is because your squared term is negative. Okay? When this happens, my strong suggestion to you would be to factor out a negative 1. Okay? Factor out a negative 1 from any time the x squared term is a negative. Because when I factor out a negative from both of those terms in the bottom, my x squared becomes positive and my other number becomes a negative. And what does it look like? What's the denominator look like now? It's a binomial. What type of binomial? Say it again. A perfect square binomial, which means that I can factor it like how we did those other problems that were perfect squares. How does x squared minus 1 factor? X plus 1, x minus 1. I take the square root of x squared, I take the square root of 1, and that becomes my a and my b that I plug into that formula. Does everybody see that? I just now have a negative 1 on the outside because I switched the sign. And the reason why I switched the sign is because now, do you see something that I can cancel out? My x minus 1s. If I left it the other way, I wouldn't have been able to cancel those out because it would have been a 1 minus x, not an x minus 1, and there is a difference. Okay, so in this one, with your bottom, okay, if I set my denominator equal to 0 and I solve this, I'm going to add over a 3x squared, divide both sides by 3, and take the square root. My excluded value should have been a plus or a minus 2. Did you guys have that for your excluded values? You always state those first, okay? Now, at the top does factor. Okay, if I make my little x, that's a 6 at the top and a 5 on the bottom. What were the two numbers? It's what? 3 and 2. Be very careful. 3 and 2. So that's going to be an x plus 3 and an x plus 2 at the top. Now on the bottom, your square term is negative. And I told you, my strong suggestion to you would be to take out what? A negative. But I don't actually can take out more than a -1, can't I? I can take out the GCF along with it. What is it? A 3. So if I take out a -3, then this term becomes a positive x squared, and that 12 turns into a -4. Now, you don't have to do it all in one step, but I am limited in space, so I did do it all in one step. Now, that denominator, that x squared minus 4, how does that factor? X plus 2, x minus 2. So my bottom becomes -3, x plus 2, x minus 2. And as you can see, what can cancel? X plus 2. So my final answer is x plus 3 all over -3, x minus 2.